Math analysis. These are the notes for 7.1 day 1. This is mainly for students who missed because of ski board team. We did the graphs of sine and cosine, so I'm going to go over those and go through this whole page of notes. First thing, the graph of sine. Typically, a lot of the times they want us to graph from negative 2 pi to 2 pi. And each side of the y-axis, I'm going to split into 4 parts. So I'm going to split in half and call that pi. Then I'm going to split this smaller increment in half, so that's going to be pi over 2. That means this will be 3 pi over 2. We'll use those increments a lot for right now. Eventually we'll start seeing stuff that has different increments, but for right now that's what we'll stick with. Same thing on the other side, so I've got negative pi over 2, and negative 3 pi over 2. We'll see that the highest sine reaches is 1, the lowest sine falls is negative 1. So I'm going to go ahead and mark those as well. And now we'll figure out what are the values. The angle values from negative 2 pi to 2 pi, remember those are radians. And if I look at my unit circle, at 0 radians, the sine is 0. Because remember, the coordinates go cos, sine, the coordinates of any point on the unit circle. So the sine is 0. So at 0 radians, no rotation, the sine is 0. So going back to my graph, that means basically I have a dot right at the origin. As I go back to the unit circle, now if I rotate to pi over 2 radians, the sine is now equal to 1. So for the graph at pi over 2 radians, which is right here, the pi over 2 radians, the sine is 1. So I put a dot there. Okay, what about pi radians? At pi radians, the sine goes back to 0. So at pi radians, I'm back at 0 for the value. And then at 3 pi over 2, the sine goes down to negative 1. So at 3 pi over 2, I'm at negative 1, so I put a dot there. And then 2 pi is the same as 0, so it's going to be right back there. And this process continues on. So I was on the axis, then I was above. Then I was on, then I was below, then I was on. This pattern will continue. So on the other side, I'm going to be below at negative pi over 2, then on, above, and then on. And then I just try to connect it with a fluid wave. It's not supposed to be pointed, it's supposed to be nice and fluid. It's called the sine wave for a reason, because it's a wave. Cosine is very similar. First thing we want to do is mark up our diagram, our graph, with my increments. Again, I'm going to go with every pi over 2. So again, this is exactly the same as it was on the sine graph. And again, we're going to see here that cosine maxes at 1 and drops down to negative 1. But cosine is going to start in a different spot. So let's look back to our unit circle. And get rid of all the red arrows I put here. I'll just say that those all represented sine. Okay, so now I'm looking at cosine, so I'll do this in green. At 0 rotation, the cosine is 1. So that means at 0 on the x-axis, I'm at 1 on the y-axis. Oops, that's not what I wanted. There we go. So actually, cosine starts at 1. And then what happens right here at pi over 2? What is the cosine at pi over 2? Well, look to my unit circle. At pi over 2, the cosine is 0. I go back, okay, at pi over 2, the cosine is 0. What about at pi? At pi rotation, the cosine is now down at -1. So at pi rotation, I'm at -1. X1 is 3 pi over 2. Right there, 3 pi over 2. At 3 pi over 2, cosine is at 0 again. And then again at 2 pi, that's the same as what it was at nothing. And again, this process repeats. Since I was going backwards here, below, then on, then above. The next one I'm going to be on, then below, then on, and then above. And then connect it with a nice fluid wave. There's a cosine wave. If you actually look at these, they are the exact same image. And by the way, they would both continue, both the red and the green continue forever. They're really the same image. Sine and cosine make the exact same graph. It's just shifted. If you look at this brought over here, you can see that they basically overlap. One cycle of sine, excuse me. One cycle of sine, or one period of sine, is just that part right there. It starts in the middle, it goes up, then back down, and back to the middle. That's one cycle of sine. One cycle of cosine is a U shape. Starts up, goes down, and ends back up. So there's two cycles of cosine graphed here. There's one, there's two. There's two cycles of sine. There's one, there's two. And again, they would repeat forever. That's also called the period. The domain and range of these, oops, that's not the right button. Try this again. There we go. The domain is from -infinity to infinity, because again, these waves, even though I've stopped drawing them, they would continue forever in both directions. So that really means I can plug in any number. For the angle, for t, and what I mean by t is right up here, sine of t or cosine of t. I can plug in any angle I want, and it will give me an answer. At no point will it give me an error. The range, though, is only between -1 and 1, meaning the lowest value is 1, the highest value, the lowest value is -1, the highest value is +1. And the reasoning is because these are triangles that we're thinking of as far as doing trig. The opposite over hypotenuse, well, the hypotenuse has to be bigger, so this can't be bigger than 1 overall. Same thing with adjacent hypotenuse. The hypotenuse has to be the biggest number. If you have something that's smaller over something that's bigger, it's impossible that it would get bigger than 1. And again, I've already mentioned this. The cycle repeats every 2 pi. That's called the period of the function, both for sine and cosine. On numbers 1 and 2, and actually number 3 as well, we're going to be looking at the unit circle. I'm not going to actually draw the circle, just the coordinates. On number 1, it's asking for what values of t, meaning what angle. So this is actually inverse trig. It's telling me the answer. I want to know what angle results in that answer. When is the sine equal to -1? All right, this first one's kind of a special case. Sine only equals -1 at one spot on the unit circle. And actually, if I go back to my unit circle, the only place, let me get rid of these real quick. The only place where sine equals -1, remember it's the second coordinate, is down here. So what is the angle so that I end up pointing straight down? That is 3 pi over 2. Let me clear those off. So that means that at 3 pi over 2, the sine equals -1. So that's my angle. remember we talked about this last semester. I could keep spinning around the unit circle with full rotations and end up right back there to get the same answer over and over and over again. The way I account for that is I say plus 2n pi. N is just any integer, so plus 2 pi, plus 4 pi, plus 6 pi, plus 8 pi, or it could be negative, minus 2 pi, minus 4 pi, minus 6 pi, so on and so forth. This accounts for all the answers forever because the answers never stop. And again, think about it. The graph of sine never stops. So answers would keep happening forever and ever and ever. On the second part of number 1 over here, now we just limit our interval. This answer that I just got is kind of the recipe to get any answers I want. So I'm going to use the recipe. So I know 3 pi over 2 is within this range. So then I'm going to take 3 pi over 2 and I'm going to add 2 pi, because again, that's what the recipe tells me, just keep adding 2 pi's. Common denominators, this would actually be 4 halves. That would give me 7 pi over 2. And I think, is that in the range? It's not. 7 over 2 is 3.5, so that's too big. So going plus was too much. So instead, I'm going to switch and go minus. So I'll try to minus 4 halves, 4 pi over 2. That'll give me, let's rewrite that. That'll give me negative pi over 2. That is within the range, so I'll write it down. But I got to see if there's more. So then I'll minus off another 4 pi over 2. So I'm taking these here. That would give me negative 5 pi over 2, which is also within the range here. If I subtracted off another 4 pi over 2, it's going to be too small. So these are the only 3 answers within that range. Again, general recipe, and then use that recipe to get specific answers. Number 2, a little bit different because now we're going to have to start looking at triangles, and this is where you've got to remember your 30, 60, 90 stuff and your 45, 45, 90. It wants to know when the cosine equals a half. First thing is that it's a positive number. If you think back to the all students take calculus, I only want cosine where cosine is a positive number. Well, that only happens in the first and the fourth quadrant. So I can cross out quadrants 2 and 3. I won't have angles there. Now I've got to think backwards and go, all right, what angle has the cosine, meaning the adjacent side, equal to 1/2? That ends up being, a 60-degree reference. If I have a 60-degree angle, the adjacent side is a half. So what this means is I could have a 60-degree reference here, or I could have a 60-degree reference down here. Either one of those results in the adjacent side, meaning the cosine, being 1/2. Okay, now for answers, I don't just say 60. For one thing, I want to put them in radians, and also I've got to remember to do my rotation. 60 degrees is 2 over 6 pi's, so that would actually reduce to pi over 3. The other angle I want to reach to is all the way down here. That actually is 5 pi over 3. It would be 1, 6, 2, 6, 3, 4, 5, 6, 7, 8, 9, 10 over 6. But 10 over 6 is 5 pi over 3. And then again, remember that I could constantly spin around the circle and get right back to the same place. The way I account for that is I say plus 2n pi. So that's my recipe for all answers forever. Now to actually get answers on this interval, I look at which ones are within 0 and 2 pi. It turns out it's just the pi over 3 and the 5 pi over 3. If I added 2 pi onto pi over 3, it's too big. Or if I subtracted, it's too small. If I added 2 pi onto that, 5 pi over 3, it's too big. If I subtract it, it's too small. So I only really have those 2 answers. Number 3, is the same idea. Again, since it just wants all the answers, I know all my solutions here are going to say plus 2n pi. I'm going to follow the same procedure I did on number 2. First, think about a unit circle. Move that over a little bit. And think all students take calculus. A there. And I go, okay, it wants sine to be a positive number. Where does that happen? That happens in the first and the second quadrants. So I'm not going to look at the third and the fourth. Now I've got to think to myself, what angle gives me the sine, or the opposite, to be root 2 over 2? That's a 45-degree angle. So I can draw a 45-degree reference in the second or the first quadrant. Either one of those angles, and when I say angles I mean from the positive x-axis, either one of those angles will give me the correct answer. Then I need to put them in radians. This would be 1 pi over 4. Every 45 is pi over 4. Then this angle would be 3 pi over 4. And again, since it wants all the answers, I say plus 2n pi. Because I could keep spinning around the unit circle and keep getting to the same place. On letter B, again, same procedure. First, figure out what quadrants you can get rid of. Okay, this time it wants cosine to be negative. Well, cosine's positive in 1 and 4. So I don't want those quadrants because it wants cosine to be negative. Now I've got to think what triangle has an adjacent, because again I'm doing a cosine problem. What triangle has an adjacent of root 3 over 2? That turns out to be a 30-degree reference. The adjacent is root 3 over 2. Now that means that 30 degree can be here, or that 30 degree can be down here. Either one of those. So let me throw that in there. So again, this means the 30 degree could be here, or it could be down here. Okay, next thing is to actually figure out what are those angles from the positive x-axis. This is 5 pi over 6. And this other one is 7 pi over 6. Since it wants all answers forever, I say plus 2n pi. On the last one of these, same procedure. And we're going to be doing this process in the next couple chapters, so that's why I'm really starting to hit it now. It seems like, oh my gosh, we're doing a lot of these same ideas, but we need to be able to do this in our head. So on this one, again, think, what quadrants can I get rid of? Well, it wants the sign to be negative, so I cross out the top two, and now I've got to think what angle gives me the opposite, since I'm doing a sine problem, gives me the opposite of 1/2. That is, again, a 30-degree reference, because the opposite of a 30 degree is the 1/2. So that means it could be a 30 degree down in quadrant 3, or a 30 degree down in quadrant 4. Okay, next thing, again, find the angles from the positive x-axis. That is, 7 pi over 6. This one is almost all the way around. That's 11 pi over 6. And to signify that it could cycle infinitely many times, I just say plus 2n pi. And there's all my answers. Okay, the last problems, 4 and 5 has a few problems on it. These go back to graphing. So this time, if you look to the top of your page, we graphed sine from negative 2 pi to 2 pi. Now it wants a lot different interval, just from 5 pi over 2 to 4 pi. So what I'm going to do, since I don't need any negatives, I'm only going to graph a positive, and I'm going to do a zigzag here just so I show that this is not proportioned evenly. I'm starting at 5 pi over 2, ending at 4 pi. Every half pi, and we saw that from back looking at the unit circle stuff, every half pi is important. Looking at this sine graph, you can see every half pi matters. That's where something changes. So that's my increments that I need to get into this graph. Go back down to my graph. So I have 5 pi over 2. The next thing would be 6 pi over 2. Well, I can just call that 3 pi. The next thing would be 7 pi over 2. The next one would be 8 pi over 2, which is 4 pi, so I don't have to add it. Again, sine goes -1 to 1. Now, if I look back up to the graph of sine I had at the beginning, this graph ended at 2 pi, which you can think of as 4 pi over 2. So that means the next increment on this axis would have been 5 pi over 2. Since it was below and then on, it must be that at 5 pi over 2, I'm above. So now I can go back down to my graph. So I'm starting above. So the next step should be on. Next step should be below. Next step should be on. Again, that's not a full sine wave. A full sine wave starts middle, up, down, and back. But I'm only looking at a small snapshot of it. The last thing to talk about is vertical transformations. These are, again, the different moves that you put on the object. Moving it, shifting it up or down, flipping it, compressing, stretching, all those things. The vertical transformations will follow the exact same rules as everything else. Everything that we've learned about how you manipulate a graph is going to be the exact same for trig graphs. So on all these, I'm going to be marking from -2 pi to 2 pi. So first thing I'm going to do on every one of these is I'm going to get my increments. Now, I'm not going to mark 1 over 2 pi and 3 over 2 pi just because it starts to get really crowded. And again, I'm going to do this on all the graphs. We'll eventually get to the point where these numbers are going to be different sometimes. But for right now, we can just think of it like we're stamping it on. They're always the same.
This is your evaluation right here.
Okay, so we have the increments. Now I'm not going to mark the -1 and 1 because they're going to change. On the first graph, I'm multiplying by 3. All that's going to do is vertically stretch the graph by 3. Normally, cosine goes from -1 to 1. That's what it looked like up top. Since it's being stretched, it's now going to go from -3 to 3. And then the graph is the exact same. I start above, then on, below, on, above. Same thing on the other side. There's 3 cosine. Again, just multiplied by 3, it's actually called the amplitude as well. On the second one, the negative out in front is going to reflect it over the x-axis, so I'm going to have an x reflection. The 1/2 is going to vertically compress it. So instead of the sine going from -1 to 1, it's now going to be compressed where it's only going halves. So if I mark this as 1 and that at -1, it's only going to reach to there and there. Sine started in the middle, and it still will. Normally sine goes up, but since it's being reflected, it's going to go down and back on, above and on. And notice it's only going up to 1/2 and down to -1/2. So it's a more compressed, almost flat-looking sine wave. On the last one, again, the negative out in front is an x reflection. The +1 means everything gets shifted up 1. So normally cosine goes from -1 to to 1. If I take that and I move everything up, that's actually going to be 0 and 2. So I just moved everything up 1. So I'm actually only graphing this above. My new center line is at 1. That's actually called the midline, and usually you put a dotted line there so you know what your center of the graph is. So I'm only graphing the cosine here. Again, it's only from 0 to 2. Cosine usually started above, but this is being reflected, so it's actually starting down below. And then I just continue my cycle. On, above, on, below. Same thing on the other side. And there's the cosine. Again, it's been flipped, so it looks more like an M than a W. And then everything was shifted up 1. And again, when I said on the axis, I actually mean on this new dotted line.